All right, I'm going to go ahead and walk us through the lesson that you want to submit for Wednesday, connecting our big ideas. So first off, you're watching these video directions that I went ahead and uploaded here. The thing that you're submitting today is going to be this task right here. And what I want you to submit is based on you using your resources. And let me explain what that looks like for me today. First off, you're going to be given these graphs. Now, these graphs are directly from our past video lessons, and also this was in your Big Ideas packet. I had some of you annotate it. Some of you did not choose to annotate this part. That's okay. It says the green graph depicted below represents the distance of a car traveling a distance in feet over time in seconds. So that means our y-axis would be distance. Our x-axis would be time in seconds. Now what you have right here is this red line right here on the left side graph is a secant line. So remember, a secant line is a line that connects any 2 points on a graph, and the graph that we're talking about is this green graph right here, which is the distance of a car traveling over time in seconds. That's why there's two different graphs on here, but what it is we have this green graph that's representing a car traveling in seconds, and what we drew is a secant line. Why? Usually we draw a secant line to calculate the average rate of change of the car's speed or velocity in this instant. But usually when you calculate the slope of these 2 points or the slope of the secant line, that gives you the average rate of change. On average, how is the car moving is what we're looking for. Whereas on the right hand side right here, you have something called the tangent line. Now, some of you actually looked this up, but tangent means touching in Greek. So it kind of looks like that. This line right here kind of looks like it's just touching this green graph at exactly 1 point. Now the tangent line right here gives us the instantaneous rate of change of the car. So in this example, basically right here, on average, between 2 seconds and 5.6 seconds, the car is going to be going at some average velocity. But this right here, if we were to calculate the slope of this tangent line, what you'd get is the instantaneous rate of change. That means exactly at 2 seconds, how far or how fast, I'm sorry, not how far, how fast is this car going in feet per second is actually what we'll know. So basically, like when you're driving and you have that speedometer that you're looking at, you're talking about instantaneous rate of change right there. You're not talking about average rate of change. That is what this tangent line gives us. So that's just a little bit of overview of the past learnings that we've been doing. Now, my expectations for this task is you're going to be answering each of these questions utilizing the tips that I provide for you here. So notice here that you have some timestamps. Here it says between 5 minutes and 25 seconds to 7 minutes and 25 seconds. You have a video that I linked here that's going to help you answer this first question. Calculate the average rate of change of the secant line above. So basically this is about a 2-minute video where I review how to calculate the average rate of change. So between 5 minutes and 25 seconds to about I think I put 7 minutes and 25 seconds. So it's like 2 minutes where I review with you how to do that. So that means I'm expecting you to, if you're stuck on the question, to go back at the timestamped videos to refresh yourself and then show me the work. Now you can show me the work by inserting pictures of your work or typing it out, but you actually need to show all your works and all your steps for credit. You should be able to do this because you have the timestamps right here. And again, if you have any difficulty or if some of this doesn't make sense, that's when you know you need to make an appointment for office hours. Now let's keep going down. For example, what does this expression represent? Now, if you forgot that, I linked up the video and the exact timestamps that I talk about this. So your answer is going to be found in that timestamp in about these 2 minutes. So again, this is perhaps it could be a separate video or it might be the same video. So it looks like it shows up here. And again, I'll put in the timestamp for that one. So that one would be between 8 minutes and 20 seconds to 10:40. 2 minutes. Then you go on to question 3. It asks you this question. For this one, I have two separate videos where I do talk about that and how to do that. Or this could be two separate timestamps in a single video. What you would do is click it and it takes you to the timestamp. See, it takes you at 3 minutes and 8 seconds. And for about 2 minutes of the time, I talk about, for example, what does H mean? A lot of you had that question about when you were annotating the big ideas packet, like what does H mean? So you want to look back at these videos and review that, and look at the other one too, because the other one is actually probably more valuable because I actually go through the Desmos graph and I manipulate what H is, and you can understand why, as H gets small, we get the instantaneous rate of change and so forth. So again, you're going to be using these time-stamped videos to help you if you get stuck. And if the time-stamped videos don't help, you want to check in with me, okay? Text me a reminder or set up some office hours. But the expectation is that you're going to show your work the way it's shown in the video, or you're going to express your understanding from what's in the video. Again, please make sure you show all the work so I could see where you're at with this. All right, good luck.